So I can make conclusions like this, very easy, right? I'll say, oh, you know what? I need to know which platform is better, if it is Mobius or if it is OM2M or if it is Acme, because these are the three platforms. I'll keep referring to this example. So hope that you relate to it. These are the three different platforms that I was talking about. So you can always go with this conclusion, right? You can say, hey, you know what? OM2M is the best solution to handle interoperability as it worked very well in my home automation system with 10 sensors. Great, right? And so because of this, let me use OM2M for my smart city implementation. So the insight that you have is I have used OM2M and it worked very well to handle interoperability. I've used it in my home automation system with 10 sensors and let's use it. Right? So this is one easy way to start, right? For example, you might be like 5 of you might be, sitting together on a lunch table and you want to decide which platform to use. So someone comes and says, hey, in my lab, I had deployed this and it worked. Let us use that, right? But this is absolutely a good way to derive some kind of conclusion or to perform some kind of experiments. Now, even if you want to perform experiments, now imagine that you have a small lab which has, let's say, 10 sensors or 12 sensors, and you want to decide, hey, we are going to have a smart city implementation in VNR, what interoperability platform to use, right? So the easiest thing you could do is, okay, let me test, my sensors in this particular, interoperability platform and say that, okay, this is the best. But that's not the good way to do, because you have just tested on a single system, right? You have just tested on a home automation system and you are saying that I want to implement it in a smart city, which is not going to be one system or one vertical, right? It might have multiple verticals. When I say vertical, again, it's a domain, right? I could have water quality, I could have water quantity, I could have air quality. So if you just test on water quality, which has a bunch of 5-6 sensors, and say that, okay, OM2M is good, it's not a conclusive evidence to say that it could generalize to all the entire system, right? And the data analysis is not really, it's not very statistical, right? You're saying that, okay, with 10 sensors, it worked. What does it mean worked? What is the average response time? What parameters are you, guiding, or what parameters are you using to say this is better than the other one, right? What are the variables that you're using? What are the variables that are kind of fixed? What are the variables that are going to change? So a lot of things will factor in, right? You have no indications of how many requests came in. If someone comes and says, hey, I have a system with 10 sensors, what does it mean? What is the frequency in which they are transmitting the data? Did you try with different frequency of data? Did you ensure that this 10 sensors had different kind of communication protocols? What kind of communication protocols did they use? Are they representative of the real scenario, right? What are the type of sensors they used, right? How many different ones, right? Within 10, how many, types of sensors are there? Each type, how many, instances of the sensor are there? So water quality, how many water quality? 2. Water quantity, how many water quantity? 3. Like that, you need numbers, right? Based on this, okay, what was the average time that was taken for each sensor to transmit data from the sensor to the interoperability platform? How much time did the interoperability platform take to give out data? So all this needs to be factored in. Right? So there are different dimensions of empirical studies. One is called in the lab. One type of study is in the lab versus in the wild studies, right? So typically where in the lab studies is what, you perform as experiments where you have a lab setup, right? So you have a lab which has a bunch of, devices. So in this case, you can think of even the smart city living lab, right? We have a living lab where we have a bunch of sensors deployed and we performed a study there. Versus in the wild, I can go out to different smart cities, right? I can go and see what kind of implementations they have and make observations from such kind of implementation, right? So it's not restricted to a lab, but I'm just going out of it. I'm finding generally what people have done and making inferences from that. So that is in the wild studies, right? Then you have qualitative versus quantitative. I've already touched upon this. So one is more about numerical analysis, the kind of numerical data that you get, and based on that you make observation. On the other one, it is more qualitative, which is you do kind of surveys, you do studies with people, you understand what they want to say. See, even in qualitative or even in surveys, you will get quantitative data. For example, you can ask, out of 10, how do you rate it, right? But that is only one aspect of it. But the study is primarily qualitative in nature, right? You get data from them. You analyze the data. They are very qualitative in nature. They talk about, okay, this is good because of these reasons, this is bad because of these reasons, but it's not substantiated by any numerical evidences, right? And then you have primary versus secondary studies. This was already explained by Raghu last time, so I'll just pause to ensure that you're all listening. What is the difference between a primary study and a secondary study? In terms of systematic literature review or general study is fine. I'm not talking with specific to empirical study here.
Primary study means if anybody initiate any concept for the first time, then it may be considered as primary study.
Okay. What about the secondary part of it?
In continuation with the primary studies, if any different directions are formed, if you want to work in different directions, then it might be considered as secondary study.
Come again. So in different directions are?
Uh, on the if once the
Yeah.
primary study is started,
Yes.
if we find different directions on the primary study, then it might be considered as secondary study.
Correct. Right. So you perform a study initially, and then based on that, someone else performs a study on top of it, top of all these primary studies to come up with some kind of an output. Right. And then like last time, there is also tertiary study where you take these studies and perform a study as a meta study on top of all this. Right. So there are this multiple type of study, but I'm not going to delve into this because this was already covered. But I'll just go more deeper into in the lab versus in the wild, and then we'll pick up specific type of empirical studies as examples, right? So in the lab, there are three different type of studies that you could do. There are controlled experiments, there are literature reviews, there are simulations. So literature reviews is already covered, so that is done. These are generally the type of experiments you could perform, right? So controlled experiments are, of course, and the first example is the kind of the one that I talked about, interoperability platform. It's a very controlled experiment because you are performing this experiment under certain assumptions, saying that okay, with this many IoT nodes or these kind of systems, these are the assumptions that I'm making. Under these assumptions, with these as parameters, this platform is better than that, right? So you are performing a very controlled experiment where the experimental setup itself is controlled by certain assumptions that you're making on certain kind of parameters. When I say certain parameters, you're saying that, for example, I'll give more examples as you go along, but you might talk like, okay, I'm taking an assumption that I'll get 100 requests per second into my system. 20 different sensors are going to constantly, send data. These are the different type of sensors. So you make assumptions on all this and you fix these as the initial assumption, and based on that, you perform studies, right? Then you have literature reviews that we already saw, and then you have simulations. So in simulations, you don't really have a system, right? So for example, I want to decide which is the best interoperability platform for my use case, but I don't really have a system that is deployed, right? I don't have a massive IoT system that is deployed. So what you do, you perform a simulation study where you are going to ensure that you try to mimic the real setup as much as possible. You use some kind of simulators. So in that case, what you do, you don't rely on one simulator in order to ensure there is correctness to your study. You try to take different kind of simulators. You perform the same, you take the same kind of setup, apply it in multiple simulators, you gather data from them, and then you make a conclusion. So you don't have a real system, but you simulate the system's behavior using some kind of a simulation platform, and based on that, you get observations, right? Then in the wild, again, there are many things. I mean, if I keep explaining, I can take more time on that, but I'll just touch upon those. So there are different types of in the wild studies, like quasi experiments, where, for example, you want to introduce a new approach to a team. So, for example, in VNR, let's imagine that we want to adopt a particular style of doing research, and you want to see which works better, right? There are two different types of research, and you want to decide which research works better. So what you do is you create two different groups. You say group one will follow this kind of research methodology, group two will follow this kind of research methodology, and then we understand based on their observations what is better than, if research one is better or research two is better. I mean, you also might shuffle them in between, right? Then there is also case studies. So case study is where you take one specific instance. So for example, I don't want anything to be generalized, right? So for instance, imagine that VNR builds a smart city living lab, and we want to tell to the community about how or what kind of approach worked well for VNR, right? So we might want to write, or we might want to perform a study saying that developing IoT smart city architecture, or coming up with smart city architecture for IoT systems, a case study in VNR, right? So we based on our experiences, we study what worked well, what didn't work well, and we put it out as a observation to the community, saying that, hey, in our case, this is what worked, this is what didn't work, and these are based on these kind of factors. So if you are building a similar kind of a system, these are some of the inputs that we have from our side, right? So you derive inferences from what you did in a very particular case, right? So the study, there are, of course, these kind of studies will also come with a lot of limitations, because by definition they are case studies. So you have taken whatever you have deriving as output is just based on a particular case, which may not generalize across. But since you're already calling it as a case study, you are just saying that if other studies are going to be similar to this, then they can possibly adopt such kind of such kind of approaches that work well for you. Then survey research. Survey research is where you create a nice research surveys or questionnaires, and then you go to each researchers or developers, ask their opinions, right? For example, we want to decide on the interoperability platform, right? We know that, for example, some of you are very much into already IoT labs. Like I know, Ramesh, Dr. Ramesh is already into it. So we say, okay, now let us ask all these people who are building IoT labs. Let us go and give them a survey, circulate a survey to them, and let them answer a bunch of questions. Now, how do you design this questionnaire? What kind of questions needs to go in? All these are also very systematically done, right? I'll take you through some example. But now you will give these questions to the bunch of people who are participating in the study. They will answer those questions. You will get the results from them, which is the answers they have generated. Now you'll sit together, you'll put all these answers together, and based on that, you will derive some kind of insights, saying that, okay, based on all this platform is better than the other one, right? Then there is also ethnographic studies, which is much beyond what we are anyway doing. So I will just briefly say, for example, you want to understand what kind of development practice might work with different type of groups, right? You might come back and say, oh, in India or in these kind of setup, these kind of development practice work well. In Hyderabad, in this particular region, this kind of IoT deployment works well, versus in some other region it may not work well, based on people involved, what kind of inputs they give, and so on. What kind of people are involved in the development, and so on, right? You are mostly studying the behavior of people who are involved in building systems. What kind of behavior will promote more faster development, and so on. So it's very specific to more humans are involved, what kind of backgrounds they come from, and then based on that you derive insights from their observations of how they participate, and so on. And then there is also action research. So action research and case study has a lot of intersection, right? I will also give an example of an action from case study that we did, where you want to, for example, imagine that I come as architect to VNR's IoT, VNR smart city system, right? So imagine that I come as a instructor, or I come as a consultant in architecting a smart city for VNR, right? Now I am going to propose something, right? And that thing you are going to adopt, and based on how you have adopted, what kind of results came out of that such kind of an adoption, I'm going to come up with some kind of observations. So I'm actively participating in the development of smart city at VNR, and based on that I am coming out with some kind of an insights, right? That is action research. But in a case study, I may not be actively involved. I might be a passive person. You will tell me, hey, this is what we did, this is what worked for us and everything. And based on that, I'm making conclusions, right? So in a case study, I may not be an active participant, but in an action research, I am proposing an action. You are taking that action, and based on the action, what came as an output, that inferences I am deriving, based on our experience, and then putting it out into the community. So that is what is action research all about, right? So these are the different kind of, experiments you could do. These are some examples. For example, can LLMs generate architectural design decisions, right? So this is a study that we did, right? It's an exploratory empirical study where we just did a study on if LLMs could be used in a particular aspect of software architecture design, right? I don't want to get into what of it, but you wanted to see which LLMs could be used. Can LLMs even be used? If they can be used, what kind of LLMs will work? So we just wanted to perform an empirical study, right? So very in the lab kind of a study, right? Whereas on the other side, some of my colleagues, they did a very interesting study. They said on the deployment of IoT systems, an industrial survey. They wanted to understand how IoT systems are typically deployed in industry, right? What kind of architectures are used, what kind of decisions are made, what are the key design aspects that people consider when building IoT systems or deploying IoT systems in an industrial scale. So here, if you notice, there are, they say that we conducted with 66 IoT architects from 18 countries across the world, right? And based on that, they have been, asked to fill up some surveys, and based on their output, people are going to derive conclusions on what kind of deployment works well, in what kind of settings, what are the things that we need to consider when deploying IoT systems, and so on and so forth, right? So this is very much in the wild kind of a study, right? And it's very qualitative in nature. right? I hope you understand the difference here. Whereas the first study is very much quantitative in nature. We perform, we get some numbers, and based on that numbers, we will come up with some kind of an insights and so on. Right? Okay. So, of course, qualitative versus quantitative, I already focused, so I'm not going into the details of this, but if you want, you can always read the slide itself to get more details. So we'll go more into the type of empirical studies. So broadly, there are three things that we will talk about. One is survey, then the second one is case study, and the final one is experiment. I've kept experiment in the final one very intentionally because I'll go more deeper into it, right? So survey we already covered. So what we basically do is, the idea is, a system you collect information from or about people, right, to explain, compare their knowledge, attitude, behavior. It could be anything. You want to know what kind of behavior works well for, building an IoT system, right? For example, you can say developers who are building IoT systems in the morning are more productive developers. Sorry, someone.
1 minute, Senator.
Kirtan, are you trying to speak? Okay. Yeah. Okay. So
Sorry,
a survey
I missed.
Hello. I don't know. Okay. So a survey is where you are, it's more about collecting information. It could be anything, right? It could not, it is not just about, oh, sorry, Ramesh, you had a question. I'm sorry.
Sir, I have muted it. You can carry.
Oh, sorry. Okay, thanks. Yeah, so it is about a system where you are collecting information. It could be about people who are involved. It could be by the people who are involved. They might provide you some kind of information, right? For example, you want to know what kind of behavior of people help them become very productive in research, right? This is probably an idea, study you want to perform, right? So you observe, for example, you might say, okay, people who do research from morning 9 to 5 are more productive than people who do research from evening 5 to 10. I'm just making up, yeah? So this kind of studies you want to perform. So what do? You survey people, what kind of habits do they have? When do they perform more research? Do they perform research in the morning or the evening? You create a set of questions, and based on this question, you get answers from people. And based on that, you will come up with some conclusion saying that, okay, people who tend to do research in the early morning hours seem to be more productive because of these reasons, versus like that, you will come up with conclusions, right? So here the whole point is you do interviews and questionnaires, right? They are the primary means of gathering qualitative or quantitative data. As I said, it could be quantitative as well. You can say rate your performance or rate your productivity levels when you work in the morning versus rate your productivity when you work in the evenings, right? You will get quantitative data as well. Also, you will get descriptive data. Combining all this, you will come up with some kind of evidences, right? Now, the main thing about a survey is deciding what will be the group who will be involved in answering the questions. So you cannot say, I wanted to decide whether morning is better for doing research versus evening, and I surveyed all the people, and all my candidates are people who get up early in the morning. Then of course your result is going to say that doing research in the morning is better. Right? That's not a very good way of doing it, right? So you need to find a representative sample that covers people of all different maybe backgrounds, different stages of their research career, different time of doing research. You need to collect all this information, and then you form the bunch of people who will be participating in the study, and then you do the study, right? Another example is, for instance, when COVID vaccine came up, right? This is a very interesting example. Now, can you say that I'm going to release a new vaccine? I've tested on all the patients aged between 10 and 20, and the vaccine seems to work fine. So because of this, let me release the vaccine. That's not the good way to do, right? Rather, what you do, you ensure that you have participants of different age groups, you have participants even having some kind of background, maybe some pre-existing illness and so on. You consider all different combinations. You see that this sample is representative of the entire world's population. And based on that, you perform this experiment, you come up with conclusions, you talk to them, you get feedbacks from them. And finally, you say that, okay, based on all this, I feel we are ready for the next level of certification. And then you go to the next set of authorities who are going to finally say that, okay, whether this vaccine could be used or not, right? By the way, what I wanted to say is it's very much used. This kind of empirical research are the primary basis for most of the medical advances. Yeah. Okay, so yeah, as an example, as I said, there is on the deployment of IoT systems and industrial survey. There is also Agile for MLS, right? So for example, we came up with a Agile methodology, and we wanted to see if it works well. So we did a study in an industry. We gathered their feedback, and based on that, we said to the community that, okay, this is something that you could be using for building machine learning systems, right? So this is a study that we did. So again, I'm not going into the details, but typically if you want to do such kind of a study, it involves a lot of things. First is you have to plan the survey, where you decide what should be the goal of the study, right? Why do you want to perform the study? What are the goals of the study? And based on that, you might even come up with a bunch of research questions that I want to answer this research question at the end of the study, right? And then you identify different targets, right? You want to say, okay, who are the people who are going to be participating in the study, right? When we created this agile methodology, it was a kind of a case study. As I said, it was within an organization, but we wanted to ensure that we pick people from different, experience levels. Small developers, junior developers versus senior developers versus architects, so different kind of people. Then you created the design. Now, what kind of questions should be, you need to put so that you could answer all the research questions that you have. So you design the survey, and then you send out the, survey for people to answer, and then they will answer and they will give you back. And based on that, you perform all the analysis and come up with some kind of conclusions, right? So this is typically how, a survey study is done. Then you have case study. So of course, case study, as I already said, it is about, it's an empirical inquiry, but you want to investigate one instance, right, of a phenomenon, right, in a real life context. So you want to say, okay, what is the best interoperability platform to be used when you're building smart city for water quality, vertical. I'm just giving an example, yeah. So you might come up with saying that, okay, interoperability platform, optimal interoperability platform design for smart city system in water quality domains, IIIT Hyderabad Living Lab case study, right? So I might say in Living Lab at IIIT, this is the setup we have. In this setup, we did like this, and based on this, we can say that if you are building a water quality, water network, you can use this interoperability platform, right? We can come up with kind of conclusions, right? So there are again a bunch of examples. As I said, the Agile for MLS comes again here because it's a kind of a mix of action research and a case study. So that's why it keeps coming here. But for example, see, you can see a title, an IoT model for optimizing downtime management, a smart lighting case study. So someone has come up with a smart lighting setup in a small place, right? So they have a bunch of smart lights they have kept, and they want to come up with a model that could optimize the downtime, right? How do you ensure that the system does not go down, right? So they've come up with a model that ensures that it optimizes the downtime, and that they are saying they are creating this approach, but they are saying that this is very much specific. The work that we have done is within this particular case study of a smart lighting scenario. So if it works for air quality or water quality, they don't know, but it works for their smart lighting under certain assumptions, right? Based on that, they are coming up with conclusions. Now, the final thing that I want to talk about is experiment, right? So experiment is where you have, it's a study where you manipulate one factor or variable of the studied setting. So I'll explain more about this, but don't go into the definition as such. But basically the idea is you want to identify what are the variables that play a very important role, in a real deployment. So for instance, in a 1M2M platform, if I want to talk about 1M2M platform, I want to think about many things. On one side, I want to think about how many sensors can connect to this platform, what kind of protocols can be supported, right? Because my interoperability platform should be able to do all this. On the other side, I want maybe, other users or third-party clients are going to access the interoperability platform to get data, right? So how many requests are going to come into the system, right? What will be the nature of such kind of request, right? Whether it is going to follow a Gaussian distribution or a Poisson distribution, right? What are the usual numbers we get? How many requests per second comes into my system, right? What is the latency of serving a particular, request? On the other side, how much time does it take for a sensor to send data to the platform? So all these are different kind of variables. So when you do a study, you need to ensure that you factor in all these different kind of variables in their different combinations, so that you can ensure that when you provide result, anyone should be able to use it. It should be generalizable, right? That's the whole point of doing this study, right? And based on all this, you establish laws and theories saying that, okay, this kind of methodology works well, or these kind of platforms are best suited for smart city scenarios. In a more intuitive manner, of course, the idea of experiment is it models key characteristics of a reality in a very controlled environment, as I said, right? So you always try to perform it in a lab with such a certain kind of assumptions, and then you keep, manipulating these variables with different combinations, different kind of settings, and finally you say that, okay, I've tried all different settings, all different combinations that are representative of a real world scenario, and these are my conclusions, right? Okay, so let's go to some concrete examples. Right now, I'm going to give some, process how we followed in such kind of an experiment and how did we come up with outcomes, right? So I'll take two examples just to ensure that there are not just very specific to IoT, but it also generalizes across domains. One is an exploratory study that I already talked about 1M2M platforms. The other is a recent one that we did. It was just published in a very good conference. Which was about small language models, right? People talk about large language models, but we wanted to do something with small language models. Now, these models were deployed on edge devices. That's why I've picked this study for this particular group that I'm talking to, right? So the title is Small Models, Big Task, right? So there is this thing called function calling. So if you go to an IoT device that can listen to audio and say that, hey, like Alexa, right? So you say, hey, Alexa, switch on the bulb, right? Now, today, if you use a large language model and say switch on the bulb, it will convert that saying that, okay, the action to be performed is bulb switch. And it will also probably pass a parameter saying that 0.7, which is the brightness of the bulb to which it will be switched on. Now, we wanted to see if small language models can perform such things, because if small language models can perform that, we can actually deploy that in edge devices, right? All the different nodes that we have, like Qualcomm's node or an NVIDIA Jetson and so on. And we actually did that test also. So these are the two studies we did. And we wanted to see if small language models are good, how mature they are, and so on. So we want to understand the maturity of small language models in this task of function calling. So the first thing that we want to always do in this kind of setup is we have to start with a clear goal. So what is the goal of your study, right? So there are multiple ways to formulate the goal. One of the standard way you can always follow is something called goal question metric. So you identify what are the goals that you want to achieve by performing a study. You define the research questions that will allow you to achieve the goal, and then you define what will be the metrics in which this will be evaluated. Each of the questions will be evaluated, right? So if you do interoperability platform study, how will you say which platform is better than the other one? So you'll say, okay, let me define metrics like response time, latency of the sensor sending data to the system, right? How much throughput will the platform offer, and so on. On the other side, I want to see how accurate is the small language model. If I attack the small language model with something called prompt injection, where I can talk something like, switch on the bulb tomorrow, but it might just switch on the bulb now, right? So I might just add an extra word that might manipulate the whole context of the LLM. So how does that impact the system? So all this I might want to study. So how do? You just define a goal like this. You'll say, for example, here I'm saying the primary objective of the study is to assess and compare multiple architectures based on the 1M2M standards, shedding light on their key characteristics. I'm already saying performance metrics, scalability, and adaptability. And these can be defined as following, right? Following the GQMA, which is the goal question metrics approach. And we clearly write, we say, analyze the architecture of interoperability IoT systems for IoT for the purpose of what, right? What is the purpose? So we say for finding out their impact on performance by performing multiple intensive experiments. So how are we going to do it? From the viewpoint of small, software architects and researchers, and what is the context in the context of smart cities. Similarly, you can see here also, right? We follow the same approach. We say analyze something for the purpose of something with respect to, what kind of parameters from the viewpoint of whom, right? It's about researchers and developers, and in the context of function invocation, right? So you define a goal like this. And once the goal is defined, you can define research questions. So I'm not going into the details, but for example, in interop study, we said, when I say interop, it's an interoperability study. We said we have 3 research questions. So we said, what are the key characteristics of the interoperability, system architectures? How do different frameworks compare with respect to metrics such as latency, throughput, and resource utilization? So we wanted to compare the 3 platforms in these parameters. And what are the scalability and adaptability aspects of each architecture to accommodate large-scale IoT deployments? So we have already said large-scale, so we have to justify why it is large-scale, right? We have put this as a question, right? So you can, or in the other case of an SLM, we are asking questions like, can SLMs be used in a zero-shot settings? What do happen if you do a few shot? When you do fine-tuning, does it actually help? And how do they perform when deployed on an edge device, right? So these are the different questions that we had on an SLM study, right? So the first step, once you define the goal and research question, is you should have a clear study design, right? So for example, you need to, I'll come back to this, but you need to, when you are performing a study design in the case of an interoperability framework, we said, okay, what will be the design? The design is, we are going to define the testing environment in which we are going to perform this kind of experiments. We are going to identify the key performance metrics. So what are the metrics that we are going to apply? Then we select load testing tools, right? What are you going to use as a tool to actually simulate the real load, as well as you already have a real load, but we also want to go beyond it, like, because we said large scale. So how do we extend it? And then actually perform the test and gather the outputs, right? So we have a very clear study design where we define what will be each step. And in each step, we are also writing what we are planning to do, right? Similarly, in the case of an SLM also, we had a very clear study design. We said, in order to perform this experiment of small language model, first we need to have a bunch of data set where we could actually perform this. So how do we ensure we pick, good representative data set? How do we decide on what LLMs we should test on, right? So there need to be a process to follow. So how do we decide which LLMs to select? So we went with some leaderboards, right? So we picked some leaderboards that are publicly available. From that leaderboard, we combined them and we selected top 10 LLMs, right? Top 10 SLMs from that. And then we have an experimental setup where we said 0 shot, few shot, and fine tuning. And then we also added prompt injection, where injected the prompts by, again, how do we inject the prompts, right? So for that, there are some research that has already been done. So we took inspirations from that. Based on that, we came up with some ways to inject prompts. Because you cannot randomly say, I liked it, so I injected the prompt in a particular way. Right? Prompt injection means you are just adding some noise to your text. So you are saying, hey, how are you? Instead of, hey, how are you? I'll just add a noise like, okay, hey, how are you? Not good. Like, or I might just say, hey, how are you? 1 + 2. I might just add some random text, right? But how to add such kind of text? There are already existing research on that. So we took that and we used that to inject the prompt, right? And then what you also do is then you perform the evaluation, right? You apply different metrics, perform the evaluation. You select the best performing models from that. Then you use that models and deploy them on edge to see how do they perform on edge. Now, even in edge, what do we want to compare? That also is represented here. We wanted to compare their latency and memory usage. And finally, we come to their analysis stage. So your study design has to be absolutely clear. So in fact, in these kind of empirical studies, once you have a study design like these, you also send it to some experts in the community who will validate the study design. So you create an initial study design, you validate the study design. It's called a pilot approach. And they will say, okay, this study design is good, or there are some flaws here. And then we take the feedback, we improve it, and we finally finalize a study design, just like how you do a systematic literature review, right? Very much parallel to that. I mean, the approach is, I'm just trying to give a parallel here. So now you're performing the study. So what do you do? We selected these 3 platforms. We said these are the 3 different architectures. I'm not going into the details. So Acme has a particular architecture. It's based on Python. Mobius is based on Node.js. OM2M is based on Java. Because they are using, I'm using technology here because they are following a certain technological background. Their architecture is also a little different, and they have their own pros and cons. So now, the actual study, right? We have to ensure this is generalizable. So what we do, we took a real workload. So we have our real workload that comes to our Smart City Living Lab in terms of how many requests per second and so on. And we applied it to 370 nodes across all the verticals. So that is one workload we have. On the other side, we also created synthetic workloads where we simulated different patterns of requests that might come in as a futuristic thing, right? Now we applied these different things to all 3 different systems. So we technically got around 48 tests, right? 48 different types of tests. We took all the tests. This is just one kind of a graph that we have. There are like plenty of graphs. If you go to a website that I will cite, you can go there and see all the different graphs that we have as an output of the study. And based on that, we are going to make some inferences. So here, this is the graph about user request versus response time for different kind of workloads. So here you'll say real workload, get request, real workload, Poisson distribution, right? With a get request. Here we have real workload Poisson with post request. So both get and post on real workload, synthetic workload. So all different combinations on all 3 different systems, right? And then based on this, you are coming up with some kind of inferences. And then the inferences that we got is, okay, in all 3 metrics, we consistently see that Mobius is better than Acme, is better than OM2M, right? And then of course, one important thing in these kind of studies, whatever you do, it should be replicable, right? Which means that someone should be able to replicate it. So you should probably provide all this data. Maybe if you want, you can create a nice website where you have, so if you go to this website, you can actually see the study results, how we perform the study and everything, right? Or you can just create a repository where you could put all this information so that someone can access it. You can put it in a public GitHub and so on. So this is very important in empirical study. It's a mandatory thing, especially in software engineering community, where whatever you do as empirical study should be made publicly available, because people should be able to follow the same step and replicate it. So then you provide the very important part of such study is not just coming up with some results. It's also about providing some kind of key takeaways to the community, right? So what can people get from this? You performed all this study, great. You ensured it is very systematic in nature, wonderful. You got some results, wonderful. But what next? What can you provide for this community? What are the takeaways of your output of your study? What can you say to the community that this is something that they should do as next step, or this is something, the maturity level of the current technology, where we need to do, what we need to do, right? So all this thing should come as an output at this point, right? This is just an example where we are saying that, okay, Mobius is great, but it also has some kind of challenges. So maybe those are the challenges we should focus on future kind of interoperability. And we also talk about what kind of architectural design choices impact the performance. So if you are designing a new interoperability platform, what you could avoid versus what you could consider, right? So yeah, so this is one example. Another example is, so this is one takeaway part, but even before takeaway, when you do findings for the research question, now going back to the small language example, right? So for each research question, we come up with findings where we, for example, in RQ1, which was about zero-shot and small language models, we say SLMs fail to generate accurate function calls in zero-shot settings because we have some numbers. We are not just randomly saying it, right? We have performed an extensive study, and based on that, we are coming up with some findings. So for RQ4, for edge devices, we say that edge devices deployment shows that, for example, DeepC Coder achieves the best balance between performance, latency, and memory usage. We deployed it in edge devices, and we came up with such kind of an inference, right? So we also observe that models consume about 5x less memory on edge devices than on servers due to GGUF. The GGUF is a particular format of compressing your model after a quantization in a particular, it's a representational format that is supported by many providers. So you take it and deploy it, and then based on that you derive outcomes. So give clear takeaways, right? So if you see this small language model paper, we have taken, given takeaways like lessons learned. We say, okay, our study reveals several key insights into function calling capabilities of small language models, and then we provide a bunch of lessons that we have learned by performing the study. So that are more about what are the learnings on performing the study, so that someone else who wants to do this can use these learnings in their research or in their practice and so on. But we also do this, right, which is the second part, which is what more needs to be done. So, for example, we say, what should be the research? What should be the research focus on software engineering? I mean, I'm just giving some glimpse. You can go to this paper. We have future research for SC. We are also talking about what needs to be done in the practice side in terms of developers, what they should do, right? So we provide these kind of insights that we'll say, for example, SLMs present an opportunity in terms of reimagining the integration of models with software systems to make them more efficient, right? So we say what kind of research the SC community need to do. For example, we observe that prompt injection is not very well handled. So how should you ensure that you put some guardrails when you deploy it in production, right? So those kind of insights that we give to the community, and what kind of research could be done based on the results we have. The final part is, you do all the study, you should be also very clear about the limitations, right? You cannot randomly say, oh, you know what, whatever study I did, that's it, it's the best, right? That's not the case. We also discuss about what are the potential limitations of the study, right? Yes, we did the study. Yes, everything was fine. We got some results. We have some takeaways, but there are some challenges. So for example, in interop study, we say that it is worth noting that these conditions may only particularly encapsulate the richness of all. It may not, consider every possible scenarios, because variations in workloads and use cases could yield different outcomes, right? We have tried to capture in the best way. We have tried to, consider all scenarios, but it could happen in a different use case. It may perform, in a different way, but we have tried to, capture the most of it, right? So, and also, other, so for example, in the SLMs also we say, right, there could be challenges with respect to the metrics that we have used in evaluating which model is better than the other. We may not have selected all different SLMs, of course. So some other SLMs may perform even better than what we have. But with the current state of the art, this is the best we could do. Right? So we give both sides. We say these are the limitations, but we have also done something to handle the limitation in the best way possible, and we need to be open about it. Because someone replicating the study should clearly understand what are the limitations, where it could go wrong, whereas where it could go right. So this is very important aspect that you describe. In fact, there is a very nice research paper called Threats to Validity in Software Engineering Research, which talks about how to write threats to validity, right? But that's very specific to software engineering, but I'm just saying could be of interest. So that's it. Have fun, because empirical studies are fun to perform, right? It can lead to interesting evidences that you never thought of. You could also get negative results. For example, you might think that ChatGPT is always best for programming, right? You might perform the empirical study and figure out that ChatGPT is the worst for programming. I'm just giving, it's a stupid example, but I'm just trying to give an example, right? So you can always, so you need to have clear goals. You define research questions, create a design, you validate the design, and then you perform the study by considering different independent and dependent variables, as I gave an example. Then you perform the study, you analyze the data, what are the things you could infer, what are the findings that you have, and what are the takeaways you have for the community, right? And ensure that you have clearly stated the limitations and the constraints and the assumptions that you have taken while performing such kind of empirical research. Now, all this applies to any kind of empirical research. So make claims, but it should be, the whole point of doing empirical research is you can make claims, but you can actually measure them and show them that I am making the claims based on the evidence that I have gathered by performing these kind of experiments. So whatever you say, it will be having a ground. You are not going to randomly say things. So it also gives you that power when you do empirical research. So that's all I have. I'll be happy to take any questions. We started a little late. I think now we almost reached 11:10, so it's 1 hour. But if you have any questions, I'll be happy to consider. Yeah, thanks. I have 2 questions coming from Ravi Kumar. What is the difference between running SLMs on edge devices? Okay, so this is, of course, so SLMs on edge devices means that you cannot just like that import a small language model and put it on an edge device, because we wanted to first of all see how much of SLMs are today compatible with edge devices, and we noticed that not every SLM you can directly export and put it, right? So if you want to put something on an edge device, it means that it should be able to run in that specific setup. So anything less than 1 billion parameters is considered as a small language model. So in a small constrained edge device like a Raspberry Pi, you may not be able to even deploy 1 billion model, which might offer a very high, very low latency. So what you do is you quantize the model, which means that their precision is going to go. So you might do a 4-point quantization or an 8-bit quantization, depending on how you do it. And then after this quantization, they have to preserve their behavior. So in a real system, in a general purpose computing, I might not have to quantize, I can directly deploy, but in an edge device, I will quantize. So because of the quantization, I might have a drop in accuracy, right? So that is what if you read the study, you can see, we have done a quantization and then we have deployed, and then we are seeing how much of the accuracy is preserved when post quantizations. In fact, there are also other studies that talks about what is impact of quantization on small language models or on large language models for a particular type of task. Give some use cases or problems to conduct empirical study in edge AI context. Yeah, I just gave an idea of, for example, the small language model. It's in the context of an edge AI. You can even say, I'm just giving an idea, right? So you can say that, okay, I want to do object detection in edge, right? What could be the best approach, or what could be the best model to perform object detection on edge, right? Or what kind of techniques can support optimal object detection on edge devices, right? That is more from a model side. Now I can even give from a system side, what kind of an architecture can actually, or what kind of components enable you optimal performance when doing object detection in an edge scenario, right? So where you can actually take different kind of object detection algorithm models and different kind of systems. So you might have a publish subscribe connection to an object detection model versus a layered connection, or versus a service or a container deployment that you have on your edge server, and then you can compare what actually performs better. I'm just giving some ideas as you are speaking, but There are always these kind of studies that you could do. So in fact, you could do any study. You can say, for example, which edge device is optimal for performing language model inferencing, right? You have a Google's board versus a, you have a Qualcomm kit versus a smartphone. So you can compare for a particular task. Now you want to do IoT deployment in Vienna, right? You want to build a chatbot, or you want to build a, you want to build a chatbot that can give insights on, if you say, okay, what is the temperature today? You want the chatbot to come back and say temperature is this. Now, what language model can actually be used for such scenarios, right? And what is the optimal edge? What is the best edge device that you can use in order to host the language model? This could be a part of a very nice study. I'm just giving some examples, but there are many, many things that could be done. Any internship opportunity? Yeah, we can take this up offline, in terms of internship opportunities and so on and so forth. I will also discuss with Dr. Madhu and even Professor Raghu here in SERC, and then we can, discuss this offline, I guess. But yeah. Any other questions? Anyone else? No, sir. Okay. So I think then we can conclude the session. Dr. Madhubala, are you still there? I mean, or I think Dr. Ramesh is there. Can we conclude then?
Yes, sir.
Okay, great.
Thank
so
you.
thank you.
So much for.
Thank you. I'll share the slides, and if you have anything, feel free to contact me. Yeah.
Sure, sir.
Thanks. Thank you all. Thanks for all the claps. Yeah, thanks. Yeah.